Good morning, questions to all my dear students. We have completed chapter number 10 and chapter number 11. So students, let's move to a new concept of chemistry. Yes, and learn lesson number 12, that is introduction to acid and base. Okay, so are you all excited to learn this new topic? Okay, so let's begin. We are learning chapter number 12, introduction to acid and base. Students, initially let us understand what topics are covered in this chapter. Yes, so very first we are going to learn what is an acid, what are indicators, examples of acids, properties of acids, uses of acids. Okay. Next we will learn topics like base, examples of base, properties of alkalis, and neutralization reaction. So these topics we are going to learn in this chapter. Okay. Students, can you tell answers to these few questions, like when we consume many food items, okay, in our day-to-day life. For example, we have lemon, tamarind, tomato, sugar, vinegar, salt, etc. Do all these items taste similar? What do you think? All taste same? Yes? The answer is obviously no. Yes. Now write the taste of lemon, sugar, curd, lime, baking soda, amla, tamarind, raw mango, pomegranate, water. Okay, take all these food items and just categorize this into sour, astringent, sweet, bitter, and tasteless. Okay, a small activity for you. You have to bifurcate them according to their taste. Okay. So this was the video which gives you a brief introduction to lesson number 12, introduction to acid and base. Okay. Next video we are going to start learning what is an acid. Till then, stay tuned. Thank you and take care all. Welcome back to the science class, students. After going through all the topics that we are going to learn in this lesson, let us learn or study our very first topic of lesson number 12, that is what is an acid. Yes, so let's start. We are learning chapter number 12, introduction to acid and base. Yes, we are going to understand what are acids. Yes, students, acids present in foodstuffs are called natural acids or organic acids. These acids, being weak in nature, are called as weak acids. So acids which are present naturally in foodstuffs are called as natural acids or organic acids. Organic because they are always derived from living matter, right? These acids, being weak in nature, are called as weak acids. Now some acids are strong in nature, so they are caustic and inflammatory. Yes, caustic or inflammatory. Which examples do we have? We have examples like sulfuric acid, hydrochloric acid, and nitric acid. These acids are also called as mineral acids. Okay, now these acids are strong acids, they are not weak. The skin gets burned when their concentrated solution falls on the skin. Similarly, their vapors, if inhaled, can be harmful to health. So here we are talking about acids which are strong, which are concentrated. Okay, if there is any accident where our skin gets in contact with the concentrated solution of this acid, the skin might get burnt. And similarly, if we inhale these vapors, these are very much harmful to our health. Okay, so it has to be utilized in, or it has to be used with proper care. Correct? Now students, strong concentrated acids are converted into their dilute acids by slowing adding them into water. Such dilute acids are less harmful than their corresponding strong acids. Now the question arises, if the concentrated acids are very much harmful to us, then how to utilize it or how to use them? what we can do, this concentrated acid can be made diluted, okay, by slowly adding them into water. So what we have to do, you have to add water to this concentrated acids, and then they will turn into dilute acids and they are less harmful. Got it? Now, if you taste the dilute solution of baking soda is easily available in our kitchens. So if you taste the dilute solution, you will find it astringent or bitter taste. Okay, this taste you will get. Now, substances having astringent or bitter taste and slippery to touch. If you touch the solution, it is slippery like so. For example, we have lime water, calcium hydroxide, CaOH twice is how to read it? Read it out, CaOH twice. Lime water, calcium hydroxide. Baking soda is known as sodium bicarbonate. Caustic soda is sodium hydroxide. And soap, these are all examples of bases, or these substances are called as bases. Understood? Okay. Now, bases are completely different from acids. Chemically, they have properties opposite to that of acids. They are also inflammatory to skin in their concentrated form. So, students, bases are opposites of acids. Yes. Now, their properties also differ. Inflammatory, yes, they are inflammatory. They are caustic to the skin in their concentrated form like acid. So this is something which is similar to acid properties. But other properties are opposite to acids, bases. Okay, so bases are completely different from acids. Okay, we all know that the distilled water is tasteless. Yes, we know the process of distillation in lower classes. We have learned distillation process. So distilled water is tasteless. So water is neither acidic nor basic. Very, very important property. Okay, water is neither acidic nor basic. I hope the introduction of acid is clear to you all. Please remember the examples of acid, how harmful they are to us if we come in contact with them in concentrated form. So these small things we have to always remember in the laboratory while using the concentrated form of acids. Okay. So with this, I end the video here. Later concepts we will see in the next video. Good morning wishes, my dear students. In the previous video, we have learned what is an acid. We saw the difference between what is an acid and a base. Correct? In this video, students, let us understand what are indicators. So, are you all excited? Let's begin. We are learning chapter number 12, Introduction to Acid and Base. In this, we are going to see what are indicators. Okay. The substances which are neither acidic nor basic and are chemically inert in nature. Okay, what are indicators? These are the substances which are neither acidic nor basic and they are chemically inert, non-reactive. Inert means non-reactive in nature. Now, touching or tasting of acid or base is very harmful. Yes, if we want to know the characteristics of acid or base, touching them or tasting them is not the proper method, right? It is really harmful. So what we can do here, whether to check whether a solution is acid or base, whether a substance is acid or base, how to check that? So students, there are typical indicators which are used to recognize them. We have special indicators in our laboratory to recognize them as acid or base. The substances which change their colors in presence of acid or base are called as indicators. This is the proper definition for indicators. What are indicators? Substances which change their colors in presence of acid or base are called as indicators. Okay. Okay. Next slide. Okay. Now indicators in laboratory. In the laboratory, litmus paper is mainly used to test alkali or base. This paper is made by an extract of lichen plant and it is red or blue color. Okay. Blue litmus paper turns red on dipping in acid and red litmus paper turns blue by alkali. Now students, in the laboratory as I said, there are special indicators. So litmus paper is mainly used to test alkali, that is base, okay, alkali or base, and this paper is made by what? By an extract of lichen plant. Now litmus paper can be red or blue colored. Okay, so blue litmus paper turns red on dipping in acid. Very important statement. When you take blue color litmus paper, students, if you dip it in the acid solution, it will turn red. And when red litmus paper, okay, when it is dipped in alkali or base, it will turn blue. Okay, so red will indicate what? It is an acidic solution. Blue will indicate that it is a alkali or base. Understood? Blue to red, red to blue. Similarly, phenolphthalein. Again, I will repeat the word phenolphthalein, methyl orange and methyl red are used in laboratory in solution form. Now, litmus paper. So, by the name only we can understand that it is a paper. But phenolphthalein, methyl orange and methyl red, these are what? These are all solutions. Okay, these are in solution form. Even these can be used for what? This can be used as indicators. So students, these are the laboratory indicators: methyl orange, phenolphthalein, methyl red, litmus paper. Okay, these are the solution bottles and this is the litmus paper. I hope you have understood the explanation for indicators. Next concepts we will see in the next chapter. Thank you. Welcome back to the science class, students. In the previous video, we have seen what are indicators. Yes, we have indicators like litmus paper, which is in paper form. We have indicators in solution form, like we have methyl orange, methyl red, phenolphthalein, correct? In this video, let us understand a table 12.2 which is given in your textbook, which is like a clear explanation of change of colors. Okay, when these indicators are added to acid or base, which colors do they form? Okay, which colors they form after the reaction with an acid or base, that we are going to see in this video. So let's understand this one by one. We're learning chapter number 12, Introduction to Acid and Base. Okay, indicators and their colors in acid and base. This is the table 12.2, indicators and their colors in acid and base. Okay, from the textbook. Students, if you see, we have litmus paper in blue color and we have litmus paper in red color. So litmus paper, okay, which is blue now, okay, blue colored litmus paper, it will turn red when it is mixed in or when it is dipped in acidic solution. Okay, and it will remain blue only. Okay, it will remain same or it won't change its color when it is dipped in base or alkali solution. So blue to red when it is in acid and blue to blue when it is in base. Second, when litmus paper is red, when you take a red colored litmus paper and then when you dip it in acid or alkali, let us see that. So in acidic solution, it remains same, means red will remain red only, but in alkali or base solution, it will turn to blue. That means red to blue. This is an indicator of presence of base or alkali. Understood? Litmus paper? Okay. Third, we have methyl orange. Now methyl orange, what is the color of this indicator? Students, it is orange color. Now this orange colored solution, when it is dipped in acidic substance, okay, it will turn pink. And when it is dipped in alkali or base, it will turn yellow. Pink in acid, yellow in alkali or base. Understood? Initially it is orange colored, right? Orange to pink, orange to yellow. This change we can see in the laboratory. Fourth, we have phenolphthalein. Students, the color of this indicator is colorless. It has no color, or we can call it as colorless. When this particular indicator is added in or mixed in acidic solution, it remains colorless only. That means it is dipped in acidic solution or acid is present, that is indicated. Now, when phenolphthalein is mixed in alkali or mixed with alkali or base, okay, phenolphthalein, it will change its color. That means colorless to pink color. So, pink color solution will be formed. Interesting? Okay. Next we have methyl red. Now, methyl red is red in color. When this red color indicator is mixed with acid or base, it remains red only when it is mixed in acid. But when it is mixed with an alkali or base, it will turn yellow in color. So red to red when it is in acid, red to yellow when it is an alkali or a base. I hope you have understood this table. Okay. Further explanation of further concepts we will see in the next upcoming videos. Till then, thank you all. Welcome back to the science class, students. In the previous video, we have seen different types of indicators, right? Their color change when they are dipped in whether acidic or basic solution. That table also we have discussed and we have understood. In this video, let us understand domestic indicators or natural indicators, and one activity we are going to learn to understand how we can prepare indicators in the laboratory when we don't have laboratory indicators. So what process we are going to apply, okay, or what materials we are going to take to make a natural indicators. So interesting. So let us just start learning it. Okay, we are learning chapter number 12, Introduction to Acid and Base. Okay, let us understand domestic indicator and an activity making of natural indicator. Okay, domestic indicator. On non-availability of laboratory indicator, natural indicators can be made by using several domestic substances. So whichever domestic substances or the materials which are easily available in the kitchen or in the garden, they can be utilized for making natural indicators. You must have seen yellow food stain turning red after washing its soap. Have you seen? If it is clearly visible when we have this white colored plates. We have this yellow stain on it is seen on white colored plates. Yes. And when we while washing, especially when we mix this soap with this turmeric or this food stain, a color change is observed. And this color change is result of chemical reaction between the turmeric and the alkaline material of the soap, the basic material of the soap. So here students, can we tell that turmeric is acting like an indicator for us whether while mixing it with the soap, that soap is alkaline or basic in nature. So it is acting like an indicator. Natural indicators can also be prepared from students' domestic substances like red cabbage, radish, tomato, and similarly hibiscus flower, rose petals, rose flower. These things can also be used for making natural indicators. Okay, so this is the activity that I talked about where we can actually prepare natural indicators in our laboratory for purpose or for our use. Apparatus, what all things we are going to take: hibiscus, rose, turmeric, red cabbage leaves, filter paper, etc., etc. Other things also we are going to use. We are going to see one by one. What is the activity? Students, first thing, we are going to take a hibiscus flower. We are going to remove the petals, the red petals of hibiscus flower, and we are going to rub these red petals of hibiscus flower on the white filter paper. We have filter papers in the laboratory. So we are going to just rub it on the white filter paper. So this gives what? Hibiscus indicator paper. So what is the result? Hibiscus indicator paper. Simple. Similarly, we can do this activity for rose petals. Okay, rose petals can be again rubbed on the white filter paper. Okay, and these white filter paper can be cut into small strips, and this way we get rose indicator paper. Next, we can have turmeric powder. Now, what to do with turmeric powder? This is a little different. Take turmeric powder, add little water in it. So this is a solution form now. Turmeric powder plus water. Next, what we will do, we will dip this filter paper or an ordinary paper in the turmeric water for some time. For some time we are going to dip this filter papers. Then we are going to dry it. After drying, we are going to cut it into strips. So this way, turmeric indicator paper is ready. Simple. Then let us take with red cabbage. Okay, what we can do with red cabbage? Take or put these leaves of red cabbage in small quantity of water and heat it. We have to blanch it or we have to heat it. Once the solution of cabbage leaves cool down, means after heating you have to cool down, and then we have to dip papers in it and dry it out. Okay, the color of the red cabbage will come into the solution, in the water solution, and then you can dip the filter papers. Again you have to dry this filter papers, cut it into strips, and this way red cabbage indicator paper is ready. Okay, understood how we can make natural indicators in a laboratory? Okay, after making this, a small activity we can do. What we can do, we can take different substances which are acidic or basic in nature, and we can just check what color it changes. Now, for turmeric paper, remember turmeric indicator paper we have made. If we add some drops of lime juice on it, we are going to check what is the color of the turmeric paper. That will indicate whether it is acidic or base. Yes, so lime juice is obviously what, acidic in nature. So lime water, many other substances can be taken as per our choice, and we are just going to take different indicators and we are going to see the color change. Okay, whether they are acidic or base. Clear? So I hope you have understood the table, or you have understood the preparation, okay, the activity, how to make natural indicators other than laboratory indicators which are easily available in the market. So next concepts we will see in the next video. Till then, thank you all. Good morning, wishes to standard 8 class. Students, in previous video we have seen an activity to understand how to prepare natural indicators in the laboratory. In this video, let us understand effect of acid and base on different indicators. Okay, so let's get started. We're learning chapter number 12, Introduction to Acid and Base. Okay, the topic to be covered is effect of acid and base on different indicators. So basically, students, we are going to do an activity where this is the table which is provided in your textbook. We have learned different indicators like red litmus paper, blue litmus paper, phenolphthalein, methyl orange, and then last column we have, after using different kind of indicators, okay, the samples what we have is lime juice, NH4OH, that is ammonium hydroxide, HCl is hydrochloric acid, and vinegar, which has a common name as acetic acid. So these are our sample solution and these are our indicators: red litmus, blue litmus, phenolphthalein, methyl orange. These are our indicators. Now, after reacting red litmus paper with lime juice, we are going to see the change in the litmus paper. And we have already learned the table where different indicators they change their color in presence of acidic or basic solution. Based upon the table initially that we have seen, you have to fill this table. Okay, and then you have to write the nature of the solution, whether it is acidic or basic. Okay, so last column will be either acidic you have to write or either basic. Okay, both cannot be written. So this chart, students, you have to fill it up. Okay, this is an activity for you. Okay, this is a picture which shows the effect of acid and base on litmus paper. Can you see there are two beakers? Okay, can you see the blue litmus paper is turning red? Blue litmus paper turns red in presence of what? Acidic solution. So what does the beaker contain? It contains an acidic solution. That is why the blue litmus paper has turned red. If you see the next figure, we have taken red litmus paper. Red litmus paper, it turns blue in presence of a base or an alkaline solution, right? So these are the two figures where effect of acid and base on litmus paper can be seen. Okay, now whatever experiment that we are going to perform, okay, the previous table that I'm talking about, there one thing you will notice that blue litmus paper turns red in acidic solution, red litmus paper turns blue in alkali solution. Now orange color of methyl orange, okay, methyl orange is an indicator, remember, it will turn pink in acidic solution, while colorless phenolphthalein will turn pink in alkali solution. So these are different observations that we get, okay, after performing this activity. So this is a small table that I have just talked about. We have it in the textbook. Later concepts you will see in the next video. Till then, thank you all. Welcome back to the science class, students. Students, in this video, let us understand more about acids. We are going to see some examples of acids, organic acids, what are they? And some natural acids which are called as organic acids. They are present in our dietary food. So even that we are going to cover in this video. Okay, so let's get started. We are learning chapter number 12, Introduction to Acid and Base. Okay, students, in this video, let's just understand more about acid, examples of acid, and what are natural acids. Okay, that we are going to see one by one. Students, acid is such a substance which gives H plus ions in solution state. H plus ions means hydrogen ions. Please remember, this is proper definition of acid. Acid is such a substance which gives what? It will give H plus ions, that is hydrogen ions in the solution state. Okay, for example, HCl, that is hydrochloric acid, it dissociates. Dissociates means broke down. Okay, break down in water solution. See, if you see HCl, that is aqueous solution, hydrochloric acid. Aqueous means water solution. Okay, so hydrochloric acid, okay, in aqueous solution gives hydrogen ion H plus and chloride ion Cl minus. H has plus sign and Cl has minus sign. Please remember this. Yes, this is a cation and this is an anion. So acid is a substance which gives hydrogen ions in solution state. Very good example we have hydrochloric acid. When you mix hydrochloric acid in water solution, we are going to get lot of hydrogen ions. That is why HCl is called as an acid. Okay. What are examples of some acids? Let us see. Examples of some acids are hydrochloric acid, nitric acid HNO3, sulfuric acid H2SO4, carbonic acid H2CO3. In cold aerated drinks, we have carbonic acid. Okay. Ascorbic acid, citric acid in lemon and other fruits, acetic acid in vinegar, etc. So these are examples of some acids. Students, our daily diet contains few natural acids or organic acids and they are very much mild in nature. They are not at all harmful to us. Yes, okay, mineral acids are very much harmful to us like hydrochloric acid, sulfuric acid, nitric acid, carbonic acid. Actually, these are not good, but ascorbic acid, citric acid, which are easily available in the lemons and fruits, these are good for our health. Okay, so these were lot of examples of acids we have seen. Now there is a small table in your textbook 12.4 about natural acids. Okay, if I'm asking you students, please name any two natural acids from the table. Out of 6 you can write any two. Here if you see, vinegar is an acetic acid, orange ascorbic acid, tamarind tartaric acid, tomato oxalic acid. Again I repeat, tomato oxalic acid, curd lactic acid, lemon citric acid. So this is a table, a very informative table which talks about different substances and their respective acids. Okay, so please by heart this table, it is very important. So with this I end the introduction or more detailed information of acid, what it is all about. Please remember the examples of acids. Natural and mineral, both acids are important to us. Yes, mineral acids are usually, it is utilized in the laboratories to carry out different reaction. And please remember that acids always give hydrogen ions, H plus ions. Okay, I hope you have understood this. Further concepts we will see in the next chapter. Thank you. Welcome back to the science class. Students, in this video, let us understand properties of acids and uses of acids. Okay, one by one, we are going to cover different uses and properties of acids. Okay, so let's get started. We are learning chapter number 12, Introduction to Acid and Base. Properties of acid, uses of acid. These two things we are going to cover. So, properties of acids. The very first point is acids are sour in taste. Its taste is sour. Acid molecules contain hydrogen ion H plus as the main constituent. In the previous video we have learned. Yes, after dissociation, what forms? What does it form? HCl. HCl forms H plus ions. Yes, what do we get? Hydrogen ion. So acid molecules contain what? Hydrogen ions as a main constituent. Acid reacts with metal to form hydrogen gas. Okay, when acid they react with metals, we get hydrogen gas. Acid reacts with carbonates and liberates carbon dioxide gas. Please remember these points are very important. Okay, after reaction of acid and carbonates, we get carbon dioxide gas. Blue litmus turns red in acid. The moment you dip blue litmus paper in acidic solution, it turns red. So sour in taste, hydrogen ion concentration as a main component. It liberates hydrogen gas when it reacts with metal. It liberates carbon dioxide gas when it reacts with carbonates. Blue litmus paper turns red when present in acidic solution. So these are properties of acid. Easy to remember all 5 points? Okay, now let's go to uses of acids. Students, acids are used in the production of chemical fertilizers. Yes, it is used in the production of chemical fertilizers. Acids are used in the production of explosives, oil purification, medicines, dyes and paints. Okay, they are very much used in the industries where explosives are made. Then we have purification of oil process where it is carried out. Medicines they are used in, some dyes and paints. So acid is used in all such departments. Okay, hydrochloric acid is used for the preparation of different types of chloride salts. Say hydrochloric acid. Yes, so chloride ions are present. So to make different types of chloride ions, HCl, that is hydrochloric acid, is used. Fourth point, dilute sulfuric acid is used in the batteries. Okay, for example, electric cell. So dilute sulfuric acid is used in making different kind of batteries. Dilute hydrochloric acid is used for sterilization of water. Okay, now what is sterilization? Students, sterilization is a process of making something completely clean and free of bacteria. Yes. So, have you ever heard of sterilizing milk bottles of infants and small babies? Yes, their small bottles are sterilized, means they are actually put in hot water. Actually, so sterilization process occurs when you put these bottles in hot water, boiling water. So that is sterilization, something to make free from bacteria. This is a complete process of making free anything from bacteria. Now coming to sixth point, acid is used for making of white paper from wood pulp. So in paper making, white paper making from wood pulp, acid is used. So can you see so many places acids are being used? Concentrated form, dilute form, all forms of acids are used here. Now next, let us see this property of causticity of concentrated acid and base. This is a small piece of information given in the textbook, students. Causticity is the ability to burn anything. Yes, so we can, okay, our skin can get burned if we come in contact with concentrated acid and base. That is the meaning of causticity of, of concentrated acid and base, to make us alert and aware about its cause. See, dissolution of concentrated sulfuric acid in water generates large amount of heat. Okay, when you mix water in concentrated sulfuric acid, what is generated? Heat is generated. So now teacher, if I want to make dilute sulfuric acid, so what should I do? I want to make a dilute form of acid. Students, you will make it by slowly adding water to it. Immediately, okay, at once, water is not added. Slowly and gradually, you will add water to the concentrated sulfuric acid to get dilute sulfuric acid. Okay, understood how we make this in the laboratory. Never add water in the concentrated sulfuric acid. Never, never add. It will produce enormous heat and can cause explosion. Very important point. Never add directly water in any concentrated form of acid. Okay. Bases like sodium hydroxide and potassium hydroxide are very strong and caustic in nature. They can cause burn. Our skin can get burnt if we come in contact with such strong bases like sodium hydroxide and potassium hydroxide. In the laboratory, students, safety first is our motto. In the science experiments also, in thank you slide, I remember we have given safety first. This should be our first motto or verb, proverb for this. Their concentrated solution burns the skin as it decomposes the proteins in the skin. We have lot of proteins in our skin. It gets decomposed. Okay, it breaks down. So this is such harmful or hazardous nature of concentrated acid and base we have learnt now. Okay, in the laboratory we will take care of all these things, okay, while carrying out experiments. So I hope you have understood properties of acids, uses of acids and causticity of concentrated base and acid in detail. Okay, further concepts you will see in the further videos. Till then, thank you all. Good morning wishes to standard 8th class. Students, in the previous video we have learned in detail about acid, its proper definition, reaction. Yes. Then we have seen properties and uses of acids in detail. In this video, let us understand base or alkali in detail. Okay, so let's begin. We are learning chapter number 12, Introduction to Acid and Base. Students, in this video, let us understand base, examples of base, formulas of bases and their use. This everything we are going to cover in this video. Students, what is a base? Base is a substance whose water solution gives hydroxide ion. Hydroxide means OH. Yes, to the prefix can you see? Minus sign, so OH minus ion. So it gives hydroxide ion. So base is a substance whose water solution means when it is mixed in water, what do we get? We get hydroxide ions. Remember, for acid it was hydrogen ions, H plus ions. So for base it is hydroxide ions. Okay. Now a very good example we have is sodium hydroxide. Now sodium hydroxide, when it is mixed in water and then when we get sodium hydroxide solution, students, we get sodium ion and hydroxide ion as the products. Okay, so NaOH is the reactant. It gets dissociated to form sodium ion, that is Na plus, and hydroxide ion, that is OH minus. So a cation and an anion is formed here also. Okay, in acid we have seen example of hydrochloric acid. In this we have example of sodium hydroxide. NaOH is sodium hydroxide. Let's see some examples of base here. This is the diagram, or these are the pictures which are given in the textbook. Okay, how does sodium hydroxide look like? Potassium hydroxide, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. Okay, so these are few examples of bases. Okay, this table is very informative. Students, these are nothing but name of the base, formulas. We are going to understand different formulas and then their uses. So which is the first name of the base here? The first name of the base is sodium hydroxide. And what is the common name for sodium hydroxide? Caustic soda. And what is the formula for sodium hydroxide? NaOH. Okay, and NaOH or sodium hydroxide is used as a washing soap. Okay, next let us see, name of the base is potassium hydroxide. Common name is potash. Formula we have potassium hydroxide as KOH and it is used as a soap or shampoo. Third we have calcium hydroxide or lime water. Common name is lime water. Okay, formula for calcium hydroxide is CaOH the whole twice. How to read it, students? CaOH the whole twice. Okay, into bracket means the whole twice. And what is its use? Lime or whitewashing. Okay. Fourth, we have magnesium hydroxide, which is also known as milk of magnesia. Formula magnesium hydroxide is MgOH the whole twice. And milk of magnesia is used as antacids. Now let us understand what is antacids. These are nothing but acidity resistant medicines. Okay, these are acidity resistant medicines. How we have Gelusil, Digene, these are all having these are all medicines which have milk of magnesia or a magnesium hydroxide as a main component of it. Okay. Fifth, we have ammonium hydroxide. How to write the chemical formula for ammonium hydroxide? Students, it is NH4OH. NH4OH. And what is the use of ammonium hydroxide? It is used for production of fertilizers. Okay, they are used for production of fertilizers. So these were some names and formulas and their uses of bases. Okay, I hope you have understood the definition of base, examples of bases and their uses. Next video we are going to understand about the neutralization reaction. Okay, thank you so much for now. Welcome back to the science class. Students, we have reached to the last section of this chapter, that is lesson number 12, Introduction to Acid and Base. We are going to learn properties of alkali or base and a very important reaction, that is neutralization reaction. So let's begin. We are learning chapter number 12, Introduction to Acid and Base. In this video, let us understand properties of alkalis and neutralization reaction. Here we are. Properties of alkalis. Bases has bitter taste. Bases has which taste? Bitter taste. They are slippery to touch. Okay, when we touch it, they are slippery to touch. Bases contains hydroxide, that is OH minus, as a main constituent. We have learned this in the definition of base. Remember, hydroxide ion is the main component here. And for acid, what it was? For acid it was hydrogen ions, correct. For bases it is hydroxide ions. Okay, coming to fourth point, metal oxides are generally basic in nature. Okay, so we have metal oxides which are always and generally basic in nature. They are not acidic but they are basic. So this point is very important to remember. Next, we are going to understand what is neutralization reaction. Okay, students, we have seen that acid contains H plus, that is hydrogen ions, and base contains hydroxide ions. Yes, H plus and OH minus ions. We know that. Okay. Salt and water are formed by combination of acid and base. So when we combine an acid and base, what do we get, students? We get salt and water. Okay, and this complete reaction is known as neutralization reaction. Let us understand with the help of the example. Students, acid plus base gives you salt plus water. Okay. Now what is the name, or which is the name of that acid? Let us take example of hydrochloric acid. If hydrochloric acid, base here is sodium hydroxide, that is NaOH. So when hydrochloric acid plus sodium hydroxide, yes, when they both combine with each other, okay, what do we get? We get salt and water. So salt is sodium chloride and water. Understood? Acid plus base gives you salt and water. Please remember always, neutralization reaction means acid plus base gives you salt and water. This always you have to remember this statement, and then with the help of examples, let us understand more in detail. That is what hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. And this complete chemical reaction is known as neutralization reaction. Understood? So this was the last section of it. Next, do you know? Okay, do you know section is very interesting. Hydrochloric acid is present in our stomach. It helps to ease digestion process. However, excessive acid leads to indigestion. Antacids are used to control this hyperacidity. This medicine contains milk of magnesia. As I said while explaining uses of bases, yes, properties of bases, milk of magnesium, that is magnesium hydroxide. Okay, medicines contain this particular component as a very important component, and it is used as antacids where to treat or control hyperacidity in our stomach. Okay, now such alkaline medicine neutralizes excess acid present in the stomach. So this is used like an for neutralization process to take place in the stomach. This alkaline medicine is used to react with hydrochloric acid. The acidity of soil increases due to excessive use of chemical fertilizers. This is another example. Now under the guidance of agriculturalist, limestone or lime water is mixed in the acidic soil. Okay, now limestone or lime water is a base or alkaline solution. When it is mixed with acidic soil, okay, it will neutralize the soil. Such alkaline substances neutralizes excess acid present in the soil. Okay, so hydrochloric acid is present in our stomach. This was one of the example. Other example was acidity of the soil. Okay, how we can utilize it. I hope you have understood these examples also. So here I end the chapter, lesson number 12. Immediately you will get a PDF, students, of question and answers that you can write down in your science long book. Okay, thank you for now. Take care all.